Welcome to this video, the third video in my series of videos on Cantor's 1895 and 1897 articles on the theory of aggregates and transfinite numbers. Section 3 is titled The Addition and Multiplication of Powers, and Section 3 starts off with the definition of union aggregates. Notice that the definition only applies to aggregates which have no common elements. The case of aggregates having common elements, if indeed there is such a case to consider, is not dealt with here. See also the comments at the bottom of page 85 and the top of page 86. We see that addition of two cardinal numbers is defined in terms of a union aggregate. There's not very much for me to say about the definition itself, which is reasonably self-explanatory. Addition depends only on the cardinal numbers of the aggregates which form the union aggregate, and doesn't depend on the specific nature of the elements of the aggregates which form the union aggregate. We've already seen this on page 89. Addition of cardinal numbers can easily be generalized to more than two cardinal numbers. An addition of cardinal numbers seems to be a commutative operation, this is point 2, and associative operation, point 3. Point 2 can be seen almost immediately, since the union aggregate of m and n is the aggregate of all elements of m and all the elements of n. The union aggregate of n and m is the aggregate of all elements of n and all the elements of m. Recall that there's no ordering assumed on either of the aggregates, the union aggregate of m and n, or the union aggregate of n and m. So there's an obvious one-to-one correspondence between the two aggregates, since every element of the union aggregate of m and n is also an element of the union aggregate of n and m, and vice versa, which establishes the equivalence of the two aggregates, and hence that their cardinal numbers are equal. Point 3 can be shown in an equally straightforward way. And then we move on to multiplication. To define multiplication, Cantor introduces the notion of the aggregate of bindings. As we see, the product of two cardinal numbers is defined to be the cardinal number of the aggregate of bindings of m and n, where the cardinal numbers of m and n are a and b respectively. As with addition, multiplication depends only on the cardinal numbers of the aggregates involved, and not on the specific nature of the objects of the aggregates. Cantor goes on to give another formulation of the product AB of two cardinal numbers by simply taking aggregates m and n with cardinal numbers a and b respectively, and effectively replacing each element n of the aggregate n with the elements of an aggregate m sub n, where n ranges over the whole of the aggregate n, and where m sub n is equivalent to m for each subscript. Note that each element n of the aggregate n is being replaced by as many elements as there are in the aggregate m sub n. Cantor shows that the two formulations given for the products of two cardinal numbers, given on page 92 and 93 respectively, coincide by describing the obvious correspondence between the two aggregates formed. It's important to note that the aggregate of bindings of m and n and the aggregate s formed on page 93 are not the same aggregate but are merely equivalent aggregates. The notation mn in parentheses is primarily used when referring to the elements of the aggregate of bindings of m and n, and the notation m sub n is used when referring to the elements of the aggregate s formed on page 93. Of course, due to the obvious correspondence between the elements mn in parentheses and m sub n, the notations could be used almost interchangeably, though I don't recall offhand any occasion of this happening in the present work. Nevertheless, if they are to be used interchangeably, it's important to recognise the distinction between the two notations. It would also seem that through these two definitions of AB, given on page 92 and 93, that we're potentially able to interpret AB as A plus A plus A plus and so on, where there are B A's, even in the case where B is transfinite. Points 9, 10 and 11 show that multiplication of cardinal numbers is commutative, associative and distributes over addition of cardinal numbers. Although full proofs are not given for these, Cantor gives brief justifications for these properties. Outlines of the details of the proofs of each of these 3 points will be shown on the screen. For point 11, it suffices to merely consider the descriptions of the aggregates. Thank you for watching. If you found this video useful, then please hit the like button and subscribe to my channel. You can see more videos on various topics on my channel, and if you have any suggestions for topics for future videos, then please feel free to let me know, and I'll try my best to put something together. Don't forget to hit that subscribe button and keep an eye out for new videos being uploaded to my channel.